Okay. All right. So I'm recording away. You guys have your devices kind of set. You've got your periodic table there. That's excellent. And then you've got your whiteboard, and that's excellent as well. I'm going to be making reference to this periodic table here, and I'm also going to open up the periodic table that you have. So let's now take a look at our periodic table for a moment, and hopefully this can open up, and I can zoom into it. All right, so let's take a look at this periodic table here. And this looks like your periodic table. And listen up, please, gentlemen. Very important information over the next 2 or 3 minutes, so please, let's listen. So, last couple of days, we've talked about ionic compounds. And ionic compounds, remember, are formed when a metal atom gives its electron to a non-metal atom, and they become ions. Now, in one of the examples that we did, and I'm going to just put an example on the board, no need to write it down, but let's say we were talking about magnesium, a magnesium atom. How many electrons or dots around the magnesium? Yep, 2, because it's in group 2. We should be to the point where we all know this, all right? We've done this for enough days that we should know in group 2, they get 2 dots. So 2 dots. And let's say that we're going to put this up against a chlorine. How many electrons are around a chlorine? How many electrons are around a chlorine? Lucas, how many electrons are around a chlorine? Yeah, how many dots are around the chlorine? 7. Excellent, very good. It's in group 7, 7 dots. Perfect. 1, 2, 3, 4, 5, 6, 7. If we wanted to complete the diagram for this compound, what am I going to need? What am I going to need here? Yep. I need another chlorine. Excellent. Cl 1, 2, 3, 4, 5, 6, 7. It's going to give 1 electron to there, 1 electron to there. It's going to make a magnesium. What's the charge become on the magnesium? After it gives its 2 negative charges away, what charge does it become? Positive what? Positive 2. Plus 2. Nice. And the chlorines. Each of those chlorines has gained 1. So it now has 8. And what's the charge going to be on the chloride ion? Minus 1. Excellent. Good. Minus 1, minus 1. And what's the formula for this compound? How many magnesiums and how many chlorides? Yep. MgCl2. Perfect. What we want to do today is we want to be able to take the name of this chemical. What is the name? I've said it a couple times, I think. Magnesium chloride. We want to take the name and be able to go to the formula. And we don't want to have to think about all these dots. Because could you imagine if I asked you to come up with a formula for like 5 compounds and you had to draw dots for all of them? You'd go crazy with the dots. So we want to come up with a shortcut way to come up with this formula for magnesium and chloride. The shortcut method comes from the charges on the ions. Take a look at the charge on the magnesium ion. 2. Notice down here, the Cl gets a 2. Notice the charge on the chloride ion. 1. Over here, the magnesium, even though we didn't write it in, gets a 1. We call this the crossover rule of coming up with the formula. We take the charges of the ions and we simply trade them around in order to get the formula. Now that's a really easy thing to do. Yep. You trade them because due to the fact that this only needs 1 electron, okay, and this needs to give away 2, because it's giving away 2, you need 2 of the opposite thing to take care of it. So the 2 from here ends up needing 2 for the other guy. Does that make sense? Because this only needs 1, its 1 charge ends up reflecting in the fact that the magnesium only needs 1. So in the end, if we can quickly come up with the charges on the ions, then we can quickly get the formulas without worrying about the dots. So let's now go to our periodic tables, because the periodic tables contain the information we need for the charges on the ions. We've already kind of come up with this very quickly when we did ions. What charge are these guys in group 1 going to become when they give away their 1 electron? Yep. Positive what? Positive 1. What charge do these group 2 guys become, Brett? Positive 2. What charge do these group 3 guys become? Positive 3. This is kind of a tricky one. What about the group 4? Yep. Yeah, so what can the charge become? Not neutral. It could be +4 or negative 4. Now, working our way backwards, these guys have to gain 1, don't they? So what charge do they become? Negative what? Negative 1. How many do these have to gain? Negative 2, negative 3. Now, that means you got to keep thinking about whether it gains or whether it loses, right? It means you're always thinking about whether it gains or whether it loses. But if we look at our periodic table, the charge is already on the table. Take a look at, and I'm going to zoom in here. If I can, I want to zoom in. Can I zoom in more? More. I want to move over to here. How do I move? Oh, I got to grab the slider. So I'm going to grab the slider over here. I'm going to move up to here. And take a look right here in this box. Okay? What does it say? Pat, what does it say in the box? Hydrogen. +1, -1. That's because hydrogen can do a little trick. It can actually gain 1, but we're not going to worry about the -1. Eric, you got your periodic table?
That's what I'm looking
It's on the floor. Just flipped off the floor. So, take a look at the lithium below it. What number is in there? +1. How about the sodium? +1. How about the potassium? So, in the box on the periodic table, will tell you the charge it becomes. Look at beryllium beside it. What charge is it? Somebody just tell me. Tyson? +2. How about the magnesium? How about, I don't even know what's underneath it, calcium. +2. Let's move over to the aluminum. Or sorry, the boron. What's the charge on a boron? Yep. +3. How about the aluminum? How about the gallium? +3. Excellent. Let's take a look at the carbon. What does the carbon say? +4, -4. Take a look at the nitrogen. What does your nitrogen say? -3. Now, you know what? I cheated a little bit. Nitrogen is a pretty complex molecule, or atom. Nitrogen can actually trade and share lots of its electrons, but in this class, we're only going to worry about it as being -3. That's why you'll see on my chart, I've got a whole bunch of numbers, but on your chart, I've just put -3. Okay, everybody understand that? What does it say for phosphorus on your chart? Just -3? Or do I have a typo? Does it say -3? Good. Look at my chart. See how it says more numbers? It's more complex. But for this class, -3. And I don't know, what does it say for arsenic on your chart? Does it just say arsenic -3? How about for antimony? And how about for bismuth? Yeah, so I've left on there for the ones way at the bottom that they can actually be a little more complicated. But for this class, for you guys, you're going to treat them all as -3. Okay? But it is more complex. Yep? Yep. No, you're looking at manganese, and magnesium is in group 2. Yeah, the ones in the middle have all kinds of numbers. And we're not going to worry too much about those. I'll talk about those when we get to them. Okay, let's look at the next row. Oxygen, what does yours say? -2. And how about sulfur? And again, look at mine. Sulfur is actually more complex than that, but for this class, we're going to just treat it as -2. And I'm hoping that's the same all the way down. Take a look at the fluorine, -1, right? The chlorine, -1, but look at my chlorine. Chlorine's fairly complex atom. It does kind of some wild stuff, but that's not part of this course. Same with bromine and that all the way down. Do I have -1, -1, -1 all the way to the bottom?
Oh, yeah.
Yeah, is that what I've got? Good. So let's do some practice right now. On your whiteboard, erase any of the doodling that you've been doing. And what we're going to practice right now is writing down the charge. Actually, you know what I'm going to do? I'm going to just pause my movie here because there's no reason for me to record that. I'm going to start recording again. And we will start the slideshow. No need to draw the picture there. That's just for some entertainment purposes. Title, Names and Formulas of Ionic Compounds. Title is right there. And as you might suspect, as we proceed to do this, you need a periodic table nearby. When we as chemists work with our, with names and calculations, we always have a periodic table nearby. I keep a little one in my pocket so that if I'm doing a calculation, I don't have to go running around looking for a periodic table. I've got one in my pocket all the time. You guys have that one that you're going to hand back to me, but there's also one linked on all of the day's work, so you can check that if you need it. Okay, so names and formulas of ionic compound. How are we going to do this? Well, we're going to start by talking, by converting the names to the formulas. So we're going to start with the name. And we're going to write a series of rules here that's going to teach us how to do this. It's funny because I did magnesium chloride as the example. I didn't even realize that was going to be this example, but that's okay. The example we're going to do is magnesium chloride. So I give you the name magnesium chloride. The first thing you do is write the symbols for those two things. Write the symbols of the metal and the non-metal as they appear in the name. Magnesium, the metal always goes first, and chloride. Now, the second step, and I'm going to just jump ahead. I'll come back. And I'm actually going to write the second step on the slide because some people are waiting here. So we've got this written down. Step 2. Step 2. Just like we did in our practice, step 2 is to write the charges in the upper right-hand corners. Write the charges in the upper right, sorry, that's more of an N, make that an R, right corners. Just like we did moments ago. So, using your table, track down Mg, write the charge up there, track down the Cl, write the charge up there. Okay? You guys can go ahead and do that because we've practiced that. Have you got those charges, Logan? Could you tell me them what they are? +2 -1. Okay? I am going to write step 3 also on the slide, so we can keep going. What you do now is you cross over the charges to the other atoms as subscripts. Does everybody know what a subscript is? You know what a subscript is? It's when you write a little version of the number beside the little version of something beside like a big letter. So the third thing you do is cross over the charges to the opposite metal or opposite atom, but leave out the charge. I just want the number. And leave off the, I guess I'll say the sign, right? The positive or negative sign, the sign of the charge. Cross over the charges to the opposite atom, leave off the sign of the charge. So I'm going to use a different color. This is going to go over to here, and you can draw that arrow in this example. By the time we do more examples, I'm hoping you don't have to actually draw arrows for this, right? I'm showing you where it goes. Put this one over here, all right? Now, we're going to put the 2 there. Oh, bumped my cart with that little foot just a little bit, but that's okay. I think we're not too far off. So we're going to put the 2 there. I should have actually made it in yellow. Going to put the 2 down there. And we don't write down ones. I'm going to put the 1 in here, but I'm now going to get to my final formula here in a moment. That means we need 2 chlorine atoms and 1 magnesium atom. Now I'm going to jump ahead, and I'm going to let everybody get caught up because I want to get to the other steps. So write the number beside it. That's great. Crossover. That's good. Write the chemical formula. You can write this step down next as step 4. Write the chemical formula. So we're going to rewrite it. But you do not write subscripts of 1. So if there's a 1, you don't put it in. We just assume it's there. And reduce to lowest terms where possible. That's going to come into play when we've got numbers that can be divided, like 2 and 4, or 3 and 6. Right now, we've got the numbers 1 and 2. They can't be divided to make it any smaller. So we make it as small as it can be. So I'm rewriting before, and actually, you don't need to write this part because you got it above, but we have a slide that looked like this. We had +2, we had -1, and then I had some red crossing it over like that. And then I wrote down a 1 and a 2. That's, you've got it rewritten down. Now we're going to rewrite. Mg1, I don't write a 1, Cl2. And that's my formula. Reduce to lowest terms, I've got a 1 in there. That's as small as it can get. I can't divide anything off. So that right there is my formula. Okay? Now we're going to do some more examples using the same rules. All right? Okay. So, examples. Let's do an aluminum sulfide. An aluminum sulfide. Write down the symbol for aluminum. Write down the symbol for sulfide, write down the charges. I'm hoping we get good to the point where we don't even have to write down the charges. We can see the charge on the paper and write it on the opposite atom right away. I'm going to do this in multiple steps, just like we've learned. Al and S. What are our charges? Lucas, what are the charges? What's the charge on aluminum? You need your periodic table. This is what we were doing earlier on with the table. Yep. You got to find an aluminum. You got to find the number that the charge is. Plus 3. And you can continue to look for the sulfide, the sulfur. What's the charge on a sulfur? -2. We're then going to cross them over. You don't need a different color. I'm just doing that to illustrate the point. I'm not even actually going to write them down over there because I'm going to go straight to writing down the AL and the S. And what number am I writing beside the AL? Lucas, what number am I putting beside the AL? There's my charge of the sulfur. There's my arrow crossing it over. What am I putting down there? And I don't include the charge. 2, because they're just counting them. What number goes over here? Sorry? 3, because I don't include the charge. 3, done. Cross the numbers over, don't include the charge on the front of them. That's the formula for aluminum sulfide. Yep. To step 3, let me finish this off, and then I'm going to do a few more examples on the board with some people, and then I'll bring the slide back. Let's do beryllium oxide. Beryllium oxide. Got to find the symbol. And as you're getting the symbol, might as well write down the charge up there, or you could think it through. I'm going to do some more on the board before we go on. So what do we got? Beryllium, symbol and a charge. Symbol and a charge. Bella, what do you got? Okay, Jacqueline, what do you got? Be plus 2. Nice. Do you have the oxide as well? Okay. Yep. O, -2. O, -2. So when we cross them over, what are the numbers going to be? Yep. Be2 and O2, but now we've got a common factor of 2. We divide off any common factors. So I'm going to divide by 2 to make it the lowest common factor. Lowest common factor. So if we divide off each number by 2, they're going to become 1s, and we write it as BeO. Okay? And that's that part there. Now, at this point, I just want to take a look at what my next part of it is, formulas to names. We're going to do a little bit of practice right now. So I'm going to, again, pause my recording. Oh, and I will go back. I will go back to rule number 3. Right there, rule number 3. And I'm just going to pause this recording for a moment. Again, pause record. All right, and we'll get the lights off. So now the opposite. Going from a formula to a name. Put the board aside, take our note. Going from our formula to a name. There is only one step. It's very straightforward. Write the name of the metal first, write the non-metal second, and change the ending of the non-metal to "ide," because that's the way we name those ions. So, you're given a Ca, simply you got to track that down on your table, or hopefully you remember what Ca is when we did our symbols and our names. Yep, Cade. Calcium. calcium. And what's that N? Logan, what's that N? It's nitrogen, so what do I write? Nitride. Nitride. Very good. Nitride. So we get rid of the ogen, the ending of the name, and we simply put IDE on the end of that nonmetal, which is at the end of it. And that's it. That's how we do it. Naming is easy. I do have another example here on the next slide. I think I just have one example. So you can just put another EG. I'll do that last slide. Then I'll let you work on the top part of it, and then we'll take it up in a few minutes. Okay? So I'm gonna. We're still ready. Okay. I've had a request that some people are not liking filling in some of this stuff on Google Classroom. If you want to, you can, and this is up to you. Let's say you're at home, you don't want to fill out the lab report or something on Google Classroom. You can print out a page and you can write on the piece of paper. What you need to do is you need to then turn it in on the computer, do a little turn in, and write me a little note. You know how you can say, send a note to Mr. Sanders? It says right there at the bottom, and say, I'll hand in a piece of paper tomorrow. All right? You can always do that. Yep. Yep. Nope, it doesn't say iodine. How do you think you would say it if you put that ending on it? Iodide. Iodide. Yep. Iodide. Yep, that's how you do it. So yeah, even for iodine, it becomes iodide. You could actually practice it going up and down the periodic table. So what will fluorine be? Fluoride, chloride, bromide, iodide, acetate, acetate. So oxide, sulfide, selenide, selenide, telluride, telluride. So, nitrogen, nitride, phosphorus, phosphide, arsenide, arsenide. This is a tricky one. Antimonide, antimonide. Yeah, I don't think we say bismuthide. Anyway, how about carbon if it was negative? Carbide. Silicide, silicide, I say silicide, silicide. Very good. So what is this one going to be? Yep. Lithium sulfide. Lithium sulfide. Notice we don't care about what numbers are in the formula. We just name the two ions. Okay, and that's that. You're going to work on your question sheet. I'm going to stop my video. And like I said, in a moment or two, we are going to take it up.